Translate and simplify word expressions, the basics. All right, so what if you have words that are written to describe an expression and you need to be able to translate that into an algebraic expression, okay, if you want to be able to simplify it. So when you're doing a strict translation, the order stays the same. So whatever order the words is in is the words that you put, the words are in is the order that you put the algebraic expression in, except when the following words are involved. If you see to, from, or than, you typically turn it around. It reverses or swaps the order in the algebraic expression when you have those words. For example, 5 more than x translates into x plus 5. Or 2 subtracted from y translates to y minus 2. All right. So if it said 2 subtract y, that would be 2 minus y. But here, subtracted from, it's y minus 2. All right. So to, from, and than typically turn it around. If you're talking about a strict translation. If you're talking about added, like added to or something like that, then with a plus, it really doesn't matter what order it's in. But now just know if your teacher wants a strict translation, then they may require you to do it in this manner. But that would be something that, whatever class you're in with your teacher, your instructor, your professor, you would want to settle that with them to make sure that you understood exactly what it was that they wanted and were asking for. So here, 4 times a number decreased by 7. Okay? 4 times a number. So 4 times a number. I'm going to call my number here x. No magic to that. You can call it n for number. You can do the, what y'all call a hashtag, what we call a pound sign or number sign, growing up for me. All right. So 4 times a number. So times 4 times a number, 4x. Decreased by, if I'm going to decrease something, I'm going to subtract. And there's to, from, or than's not there, right? So it's going to be in the same order. Decreased by what? 7. So that algebraic expression is 4x minus 7. And is there anything we can do to simplify that? No. That's why I boxed it. There's no like terms to combine. There's nothing to distribute. Nothing like that. So it's already done. 11 added to. Here's that number 2. So I'd like to draw me a little double-lined arrow there. 11 added to 3 times a number. So again, I'm going to call my number n this time. I'll probably call it something different each time. Okay, so we have 11 added to. So plus 11. Normally it would be 11 plus. And if your teacher doesn't want a strict translation, you probably could write 11 plus. But because the word 2 is there, I'm going to strictly translate it and turn it around. Added to what? 3 times a number, which is 3n. And again, I cannot simplify that. There's nothing else I can do there. So that is my final answer as far as that goes. All right? As far as the translation goes. Translate and simplify. There's nothing to simplify on that one. 3/5 of a number increased by 6. Now here, 3/5 of a number. Whew. So here, I'm going to call my number m. Okay? Doesn't matter. So 3/5. 3/5 is a fraction. 3/5. And if you've seen anything I do or if you're in my class, you know I don't like slanted fractions. And here, if you did this incorrectly, it would actually be wrong. So, again, I encourage you, whoever you are, whether you're in my class or not, don't use slanted fractions. They're too hard to know when you can and when you can't. So 3/5 of a number, of is multiply, 3/5 m. And notice it's not this. Right? We don't do that. We don't do this. Because if we do that without the parentheses, then it's wrong. So if you write it like that, that's actually wrong. Whether I do it, you do it, I don't care who does it, it's wrong. Even if your teacher allows it, it's not correct. Okay? Don't tell them they're wrong, but just know that that's not really what it should be, and that's why sometimes math can be confusing. 3/5 m, so this is okay. Put the m up top, or where the fraction line would cut it in half. Okay? So 3/5 m increased by, increased by what? 6. Can I do anything to simplify that? The answer is no. I don't have like terms, so I'm done. Nothing to combine there. All right, the sum of 2 times a number and -5 added to, good gracious, added to 9 times the number. All right, the sum of 2 times a number and. So here it says the sum of, and then you have the word and. So all of this stuff goes in. It's the sum. I put parentheses around it, but I'm saying I'm summing all that together. And is that typical word. Sum means plus, and you put that where the word and is. When you see something like that, and is where the operation typically goes. All right, so here, 2 times a number. Let's go back and call it x again, okay? 2 times a number plus negative 5. Now, wait a minute. 2 times the number plus. So if I'm adding a negative, I really don't like this. Like, I don't like two signs. But if I'm strictly translating this, it says to add some, right? Something and negative 5. So I'm adding a negative number. So that means I'm going to have something to simplify here. I don't like this scenario right here with two signs on one number. I dislike it a lot. But it comes up sometimes. So how do we deal with it? Well, we're going to add 2x plus negative 5, and then that's going to be added to. I'm going to even change. This says added to, so I'm going to do that little double arrow thing. Added to 9 times. Notice it says the number. Now, I've actually seen some books and some software packages that say added to a number, and they mean the same number. If you mean the same number, strictly you should use the word the. Now, I'm not calling them out and saying that they're completely wrong. I'm just saying, I just want to say that in case your book says a number there. If I say a number there, I mean another number, like a different one. Not the same one that you used before. If I want you to use the same one as I did before, I will say a number first and the number next. That means I'm referring to the same one. So 9 times the number. So this, since it's the number, it goes back to this one. So this is still going to be x. So added to 9 times the number. So this is 9x added to all of that stuff. Now those parentheses I just did there in the pink, they're not necessary. They're not necessarily necessary. You're adding it, but if it was subtracted or something like that, it would be necessary. So I'm going to put it there and let you, deal with it from there. So here, we're going to say, hey, wait a minute. What does plus or minus really mean? That really means a negative, okay? So this right here really means a negative. So I'm going to come over here when I simplify and say 9x plus, and if I'm going to leave it in parentheses, 2x minus 5. And then I'm going to say, okay, wait a minute. I'm going to distribute this plus sign. What is a plus? It doesn't change anything. This is 9x plus 2x minus 5. 9x plus 2x minus 5. And then we're going to take those two and put them together, and that's going to give me 11x minus 5. And now I'm through simplifying. And you could have simplified that in fewer steps. Some of you can do these things in your head, that kind of thing. All right. But I'm just saying, I'm showing you all the different things I'm doing there to simplify it. But the first thing I have to do is get it written down in an expression. And then I use what I know about simplifying algebraic expressions to simplify that. All right. So 7 times the sum. 7 times the sum. And then here's and, that goes back to sum, right? So what? A number and 3, right? When it's a sum or difference or quotient or whatever product, I'm going to put those parentheses around the words just to remind me, hey, that's a group of things that goes together, right? And that word and refers back to the operation. So it's going to be 7 times a sum, right? 7 times the sum. 7 times the sum. So it's 7, and when you multiply 7 by the sum or the difference, that's more than one term, so it's 7 distributed to that. So what's the first thing? Well, this time, let me call my number P this time. Is that okay? So this is going to be P plus what? 3. And can I simplify that? The answer is yes. Because simplify means to remove parentheses and combine like terms. So here, I'm going to distribute my 7 and get what? 7P plus 21. And that is now simplified. All right? That is now simplified. So, because we're told translate and simplify. If you were just told to translate, then this would be your answer right here. But we're told to do a little bit more. So we did a little bit more. We simplified it. All right, so the next one is a little different scenario. 2 numbers have a sum of 60. If one is W, what is the other number in terms of W? So I want W plus some other number, right? So let's just call it X, all right? The other number will say X in terms of W. So W plus X equals what? Because it says 2 numbers have a sum of 60. So W plus something else is 60. So W plus X is 60. But I want to know, hey, what is X in terms of W? So what I'm going to do is I'm going to move my W, subtract W from both sides, That cancels. It goes to 0. I'm left with x, whatever that other, you didn't have to call it x. You could have called it y, z, m, n. You could have written w plus another number and said another number equals. It doesn't matter. X equals what? 60 minus w, or negative w plus 60. And there is your, well, x equals is not part of it. I'm sorry. 60 minus w is what answers this. What is the other number in terms of w? Is 60 minus w. All right, 60 minus w. So w plus 60 minus w, right? W plus 60 minus w equals 60. Well, that makes sense. Those two things cancel. 60 equals 60, right? So that's what's going on there. That's what's going on there. All right. 1 added to 12 times a number. All right, added to. I'm going to turn it around, even though it's plus. So 1 added to, and then 12 times a number. Let's call my number n again. In fact, this time, let's use a capital N, okay? And by the way, I want to say that math is case sensitive. And what I mean is, if you choose a capital letter for something, it has to stay capital. If I choose a capital letter, you can't lowercase it, or if I give you a lowercase, you can't raise it. Or your teacher. Your teacher gives you lowercase n, you can't change it to capital N in the problem. There are some math or science problems and equations where you have a little r and a big R, a capital R and a lowercase r, or the same letter with different case, upper and lower. So here, this is going to be 12n. So 12n plus 1, you cannot simplify that. So that one is done. You can't do anything else with it. 1/4 of a number increased by 7. So again, we have a fraction. 1/4 of a number. So I'm going to call my number y this time. So 1/4 y. Remember, we don't use slanted fractions. We want that y in the top with the 1 or even with that line. We don't want it lowered with the 4 or a slanted fraction without parentheses. That would mess everything up. And then 1/4 y increased by 7. So plus 7. And you're done. 1/4 y increased by 7 is 1/4 y plus 7. 1/4 of a number increased by 7. Triple a number minus the sum of the number and 13. So triple a number. Let's see. Let's go back and call this x again. Triple a number is going to be 3 times it, right? If I'm going to triple it, if my number 7, I want to triple it. 3 times 7 is 21, right? 2 is my number. 3 times 2 is 6. So if I triple a number, that's 3 times it. Minus, all right, so it's going to be minus the sum. That tells me, parentheses, minus the sum of what? The number x, that's the same number, the number, right? So use x, the number, and that's where the sum, right? This and goes back to this sum. So the number and 13, so it's x plus 13. So it's triple a number 3x minus the sum. So minus parentheses, and then there's a plus in there because it's a sum. So we had 3x minus the sum. And then and that's where we put in the number and 13, right? So we have a little work to do here, right? We have a little work. We're going to distribute this minus. So 3x minus x, and then minus 13. And then we have like terms to combine. 3x minus x, right? This is minus 1x. We never write the 1, but we say, okay, let's like 1. 3x minus x is 2x minus 13. And there is your simplified answer after you translate and then you simplify it. So if n represents the first or the smaller of 2 consecutive integers, what is the sum of the 2 integers in terms of n? So I have 2 numbers that are consecutive. What does that mean? Like 1 and 2. Those are consecutive. 8 and 9. 50, 51, right? Consecutive integers, one number and then the very next number, 7 and 8. So if the first one is n, this is the first number. What is the second one? The second number is what? N plus 1. It's always one more, right? So if this is 7, this is 7 plus 1 is 8, right? If this is 100, and this is 100 plus 1, which is 101, right? So it's always one more. So n and n plus 1. So what is the sum? N plus 1. But wait a minute, we want to simplify that. So what we do is we distribute this plus sign. We get n plus 1. And then we say, okay, let's put that together. Put those together, we get 2n plus 1. So the sum of two consecutive integers, where the first one is n, is 2n plus 1. 2n plus 1. All right, so let's see what our next one is. If k represents the first or the smaller of three consecutive integers. All right, so before we even get any further, it's going to be k plus 1, and what's the next integer? It's k plus 1, which is k plus 2, right? Hoping the board just did something to me. All right, so k plus 1, and k plus 2. That's three consecutive integers. If this is 3, then this is 3 plus 1, which is 4, 3 plus 2, which is 5, right? That's three consecutive integers. What is the sum of the first? This is the first, this is the second, and this is the third, right? The first and the third integers. So we want this one and this one. We're going to sum them. So this is going to be k plus what? K plus 2. So that's going to be k plus 2. And we put these together, and that's going to give me what? 2k plus 2. So if we have three consecutive integers and we want to add the first one and the third one and skip the one in between, then 2k plus 2 is going to be the sum of the first and the third integers. Erase that there. So let's say that e is some even integer. And we write an expression for the sum of four consecutive even integers beginning with e. So even integer. Think about what that is. If the first one is 2, then we have what? 4, 6, and 8. That's four of them in a row. What if it was 8? Then it would be 10, 12, and 14, right? What if it was 56? It would be 58, 60, and 62, right? So we're adding how much each time? We're adding 2, then we're adding 4, we're adding 2 again, right? 2 plus 2 is 4. Then we're adding 2 again, 4 plus 2 is 6. We're adding 2 again, right? So erase all my examples here. The first one is an even number e. The next even number is going to be add 2 to it, right? Whatever it is, add 2 to it. And the next one is going to be what? Add 2 to this one, right? Which is going to be what? Plus 4. And then if you add e plus 4 plus 2, you get e plus 6. That's four consecutive even integers. Okay? So write an expression for the sum of all of these. So what we want to do is we want to say e plus 2 plus e plus 4 plus e plus 6, right? This is my first one, my second one, my third one, and my fourth one, right? So we want to add all those up. So this distribute this plus, and this plus, which again, distributing a plus doesn't change anything, right? This is e plus 2 plus e plus 4 plus e plus 6. And then we have these e's plus this e plus this e. So that's what? 1, 2. That's 4 e's. If we add this up, 1 plus 1 plus 1 plus 1 is 4. And then we have, I should have changed colors. Hang on. Let me do that to help it stand out a little more. We got these e's plus this one. That's going to be 4e. And we got plus 2 plus 4 plus 6. So that's going to give you 6, and then added to 6 more is what? Plus 12. So the sum of four consecutive even integers is 4e plus 12. Now, another scenario that I've seen this in, you know how they number a hallway maybe or street numbers on a street, mailboxes, right? Where one side of the street's even, one side of the street's odd, or one side of the hall's even rooms like 102, 104, 106, and on the other side it's 101, 103, 105. So that's another scenario. Hey, there's four consecutive rooms on the same side of the hall where they're all even numbers. What are the room numbers? Right? So it could be that scenario. It's the same thing. Any even, set of even numbers. And so that's what's going on here is that. So if v is the first or the smallest of three consecutive odd integers. So again, let's think about that. We have 3, 5, and 7. Or we have 11, 13, and 15. Or we have 127, 129, and 131. Those are three consecutive odd integers, right? How far apart are they? Look, isn't there That's 2 apart and 2 apart. So even though it's odd, the setup is the same way. The first number is V. The second number is V plus 2. We're tempted to say V plus 1 and V plus 3 here because of odd. But the next one is V plus 4. Again, if this is 3, 3 plus 2 is 5, and 3 plus 4 is 7. Right? If this is 27, then 27 plus 2 is 29. 27 plus 4 is 31. And so, again, whether it's even or odd, you use the number and the number plus 2 and the number plus 4 and so on and so forth. So it says here, write the sum of the first and the third. So again, we want this and this in terms of V. So we want V plus 4. So we're going to distribute this plus. We get V plus 4. And then we get 2V plus 4. And that's our sum of the first and the third consecutive odd integers in terms of V. All right, so I hope that this helps you when you are translating from words into algebraic expressions and then even simplifying them, which is not necessarily related to the translation, but you got to translate them right to be able to simplify them to get the correct answer, right? So if you're told to simplify. All right.